Linear motion question 1 on the Leaving Cert Applied Maths course. This is 2019. A particle P of mass 3 kilos is projected along a rough inclined plane from a point A with speed 4.2 meters per second, and you were given this diagram down here in the question. The particle comes to rest, instantaneous rest at B. The plane is inclined at an angle alpha to the horizontal, where the tan alpha is equal to 9/40. The coefficient of friction is 3/20. Show that the deceleration of P is 15g/41. So we have speed, we have tan alpha. Well, first let's start off, I can do it up here in a box. Let's just do a little diagram because we know we're going to need sine and cos alpha. Tan alpha is 9/A, and you've probably seen this triangle before. That's going to be 41. 1681 is 41 squared. 1600 plus 81 is 40 and 9 squared. So cos alpha is A/H, 40/41, and sine alpha is 9/41. So anytime you're given the tan of the angle, set up cos and sine straight away. Coefficient of friction is 3/20. Deceleration is 15g/41. Okay, so let's do a little diagram for this. We have a particle. Let's make it big so we can see it. It's this little ball here. So it's 3 kilos. We have our alpha in here. We have our 3g coming down. We're going to have my resistance, my R. We're going to have alpha inside this triangle. So coming down this way, this 3g adjacent to alpha, cos alpha, and we may as well write what that is. Cos alpha is 40/41, so 3/40, 120 g/41. And coming down this way, opposite alpha, we have 3g sine alpha. Sine alpha is 9/41, so this is 3 9s 27g/41. We're told it's going up the plane, so it's going up this way. We call our acceleration A. We do have a resistance force. What were we told? Mu was 3/20. Okay, so down this way, F is equal to mu R. So let's see what R is equal to. The opposing force is 120g. This is opposing R. So R is equal to 120g/41. So F is equal to mu 3/20 times this. And the 20 and the 120 will cancel, and leaving the 120 as a 6. So we're looking at F being 18g/41. And that would be in newtons. Okay, so let's look at my forces. F is equal to ma. Now, in a lot of these questions we've seen in connected particle and stuff, there's a tension going in this direction here, or it's string attached, and we'd say we're starting in the direction we're going, so T minus whatever's opposing it. So we actually only have opposing forces going down the hill this time. We have this F here, and we have this, I'm just going to make the R bigger so you can see it, this 3g sine alpha, or 27g/41. So minus F minus 3g sine alpha, just so you can see where they're coming from, is equal to the mass, which is 3, times the acceleration. And we're told that the acceleration is 15g/41. So what do we get for F? 18g/41. So minus 18g/41 minus 3g sine alpha, which is 27g/41, is equal to 3a. So 18/27 is 45, minus 45g/41 is equal to 3a. So in that case, A is equal to, if we bring the 3 under, it's going to divide into the 45 15 times, so minus 15g/41, which is the deceleration, 15g/41, which is what we were asked in here. So that's part 1. Part 2, we're asked to find the length of AB. Okay, well that's S for distance, so we do it here, part 2, find AB. So we're asked to find S, so let's just call SS. We were given the initial velocity of this, which was 4.2. It comes to instantaneous rest, so that means that my velocity becomes 0 before it starts moving back down the hill. And what I've just worked out is acceleration, which is the fourth variable that I can apply to this formula. V squared is equal to u squared plus 2as, which you guys have seen thousands of times at this point, minus 15g over 41. So we apply these variables to the formula. 0 is equal to 4.2 to be squared plus twice acceleration minus 15g over 41 times s. So if we simplify this down, we're going to get s to be, you're just going to type into your calculator, 4.2 squared and then multiplied by 41 divided by 30. So maybe I'll just write that out, 4.2 squared. So you're imagining the minus 30 gs over 41 is equal to 4.2 squared. We're going to multiply by 41. That's a 41. And we're going to divide by 30g. Sorry, that's going to be a positive, isn't it? Change size. We're going to divide by the 30g. And if we type this into a calculator, we're going to get exactly 2.46, and that would be meters. In part 3, we're asked, after reaching B, the particle slides back down the plane, find the speed. So we're looking for V as it passes A on the way back down. Okay, let's have a look. We're looking for V. There's going to be a new acceleration, obviously, because it stops and starts moving again. It's gone downhill, so it's going to be going faster. We know the distance. In this case, we just worked it out, 2.46. And it's starting from 0. So my initial velocity here will be, it stops and moves back down. So my initial velocity will be 0. So we need to work out our new acceleration. So let's have a look at the diagram here. It stops, let's say here, I'll just add to this diagram. It stops here and it starts going in this direction. So the forces aren't going to change here. We're going to have an F going back, but it's going to be the same. It's the same mass and the same coefficient of friction. So the only thing that changes is this is now what we're starting with, this 3g sine alpha, and we're going to take away the F. So that's my new equation, 3g sine alpha minus F. So let's write that down. 3g sine alpha minus F is equal to ma. So this will give me my new acceleration. And you can see in the first part we had minus F minus 3g sine alpha. So it's just the 3g sine alpha becomes positive because that's the direction that the particle is moving. So what do we get for 3g sine alpha? We had 27g over 41. F is not going to change. What do we get for F? 18g over 41. And that's going to be equal to 3a. So 27 minus 18 is 9g over 41 is equal to 3a. And if we bring that 3 underneath, it'll divide into the 9 3 times. So a is going to be 3g over 41. Okay, so now I have my a. We're looking for v. I have my s and I need my u. So again, v squared is equal to u squared plus 2as. We're looking for v. V squared is equal to 0 plus twice my acceleration of 3g over 41 by my distance, which was 2.46. So v squared is equal to, let's check, v squared is equal to 3.528. You could just write v here if you wanted. You guys are good enough to just jump to the answer here. V is equal to square root of that, 1.88 ms to the minus 1. So that's question 1, part A, 2019.